Welcome everyone. The question that is displayed on the screen that came from the CBSE 2025 physics paper. A rectangular coil of area A is kept uniform magnetic field such that the plane of the coil makes an angle alpha with B. The magnetic flux linked with the coil is, four options are given: BA sin alpha, BA cos alpha, BA and 0. Okay. So, since you are just listening or the audio visual thing of the Incubation Academy Learn the Basics, so here we are basically talking about the basics also. Okay, so here what is magnetic field? Okay, what is magnetic field? Magnetic field is a field or a region where the magnetic force is felt. Okay, so a rectangular coil of area is kept in this uniform magnetic field. Okay. So what is the necessity of this rectangular coil here? Magnetic field is invisible. You can't see it. But if you place a completely isolated north pole within the magnetic field, the direction, the path in which it moves, it basically shows the magnetic field lines. So the magnetic field lines is nothing but the pictorial representation of the magnetic field. Here I have drawn the figure. Okay, this figure 1 we can say. In this figure 1, these three lines, this is line 1, this is line 2 and this is line 3. These three lines basically the pictorial representation of the magnetic field. Okay, in a region, if a isolated north pole is kept, then in which directions it will feel the force, how the magnetic field is, that we get to know. Here, obviously, if I consider this is the point P, so at that point P, these field lines 1, 2, 3 are crowded. Okay, and here, if I say this is another one point Q, here they are little bit separated. So we can say the magnetic field at the point P is greater than that of the magnetic field at the point Q by the method of comparison qualitatively. Means we can't say what is the magnetic field at the point P, what is the magnetic field at the point Q, but from the crowdedness we can say the magnetic field at the point P is greater than that of the magnetic field at the point Q. So we can estimate the magnitude of the magnetic field by the method of comparison. This one is greater, this one is less, qualitatively. And if this is the my arc, this is the figure 2, we can say the magnetic field of a region is like this. If you want to know what is the direction of the magnetic field, then you have to draw the tangent. Okay, if this is the point P, if you want to know what is the magnetic field at that particular point, if the magnetic field lines is known to you, then in this particular case you will draw a tangent that will give you the direction. So magnetic field is invisible, you can't see it. You have placed the isolated north pole there, and you have observed the pictorial representations of the magnetic field of that particular region, and from the crowding of the magnetic field lines you are getting the magnitude, and from by drawing the tangent at any particular point you will get the direction. Okay, so this is all of these things are the qualitative measurement. Okay, that means we can't say what is the exact value of the magnetic field at that particular point. For this purpose, we have to consider the figure 4 and we have to take the help of one method which is called the magnetic flux. And this will gives you a idea. This is greater, this is not like that. By how much? Let us say this is the point P and let us say this is the point Q. At the point P, if you want to know the magnetic field compared to that of the point Q, okay, then you have considered an area. Here I have considered a circular one, around the point P, and we have seen that here 1, 2, 3 magnetic field lines passes through this green area. If I consider the same area at the point Q, but we have seen only the field line 2 is passes through it. So we can say the magnetic field at the point P is 3 times greater than that of the magnetic field at the point Q. Now the quantitative thing comes. Magnetic field at the point Q, if you multiply this thing by 3, you will get the magnetic field at the point P. So a quantity measurement comes. Okay. From this concept, obviously this magnetic flux is introduced. It is said that if this is the magnetic field line that is known to you, and you have considered an area around this particular point, okay, then the area vector you have to find it out, and the area vector is perpendicular to the plane of the area. Okay, if the angle between the area vector and the magnetic field vector is theta, then the magnetic flux is phi equal to B A cos theta. Okay, so this is the theoretical background of the magnetic flux. From the invisible magnetic field to pictorial representation magnetic field lines, from the magnetic field lines, from the qualitative measurement, how can you get the quantitative measurement? So this is the whole journey. Okay, now let us see the question. In this question, it is mentioned there is a rectangular coil of area A is kept in a uniform magnetic field. If the magnetic fields are uniform, then the magnetic field lines are equally separated from each other and possesses the uniform magnetic field lines. In these figures, here in the figure 1, in the figure 2, in the figure 3, in the figure 4, in all these figures, magnetic field lines are non-uniform. Magnetic field lines are non-uniform. Since they are non-uniform, so we can say that here the magnetic field lines are not equally spaced. Okay. Here the field lines are equally separated. So we can say these are completely uniform. Okay. Since are equispaced. Now if I considered an rectangular coil which is like this way. Okay. Rectangular coil. Maybe this is the length and this is the breadth. This is the length of it and this is the breadth of it, but we are concerning about the area here since the area capital A is given. Such that the plane of the coil makes an angle alpha. Plane of the coil. So this is the plane of the coil. Okay. So the angle between the plane of the coil is alpha. So this is the area vector. Then the area vector should make the angle 90° minus alpha. If I draw it from the another view, let us say this is the coil. Okay, let us say this is the coil. If I see from this side, this is the coil. Okay, and this is the magnetic field line. This is the magnetic field line. Okay, now the plane of the coil. This is the plane of the coil. The plane of the coil basically makes the angle alpha here. Plane of the coil basically makes the angle alpha here. And the area vector is perpendicular. So that is pi by 2 minus alpha. Okay, that is pi by 2 minus alpha. That is the angle between them. Okay, so in this particular case, if we will see the angle between these two is pi by 2 minus alpha. So the magnetic flux is B A cos pi by 2 minus alpha. So this will become BA cos pi by 2 minus alpha becomes the sin alpha. So here in this case the answer is option A. Thank you all of you.